Well, hello everyone. This is Chris back again with the Ancient Scholar, continuing along the lines of the pH videos. And today we're just going to take the concept that I talked about on the last video a little bit further. I would like to add that I did make a little error, error in explaining the mole. I believe I said that the mole was 6.02 times 10 to the 24 atoms or molecules or what have you. In fact, it should be 6.02 times 10 to the 23, not 24. So I do apologize for that error, and I believe that I also put a note in the description of the video, part 2, pH part 2, describing that as well. So I just want to continue on. So what I talked about is I said, well, if you can imagine that I have a container with a liter of fluid, we can imagine a pure water in there, distilled water, and I were to put 1 mole of protons, that would yield 1 mole of hydronium ions. And if I had 1 mole per liter, that would be, we'll say, my base concentration. And I don't want you guys to get too worried about all these numbers up here, but if you just remember what I talked about, let's put 1 mole in the liter. 1 mole in a liter. And then what I said is, well, let's say I take that 1 mole in a liter and I dilute it and I make it 10 times weaker. So if I start out 1 mole and I make it 10 times weaker, that gives me 0.1 moles, right? 1/10 of a mole per liter. Now let's say that I make the acid concentration, because that's what we're talking about here, another 10 times weaker. That's going to be 0.01 moles per liter. And then another 10, and then another 10, and another 10, and another 10. Likewise, if I'm down here at 0.000001 moles per liter and I make it 10 times stronger or more concentrated, that's going to go, boom, up to 0.0001. Make it 10 times stronger, 0.0001, 0.001, 0.01, 0.1, and then up to 1. So hopefully you can get a feel for what is actually going on here. Is that all I'm doing is I'm making it either 10 times stronger or 10 times weaker. And really what that's doing is it's moving the decimal point over. If I'm starting at 1 and I make it 10 times weaker, well then that means that the decimal point's going to move over 1 time, or to the left. If I make it, let's say I make it 20 times weaker, and so I'm at 1 and I make it 20 times weaker, it's going to go boom, boom, 2 to the left. 30 times weaker, 40 times weaker, 50 times weaker, 60 times weaker. Likewise, if it's down here and I want to make it 3 times stronger, that decimal point is going to move over to the right 3 times. I'm going to knock 1, 2, 3 of these zeros off. 1, 2, 3, and that's going to put me up here. Now there's actually a word that we can use to describe what's going on here, and that word is a logarithm. A logarithm. And a logarithm is, when we talk about exponents, you have to have a decent understanding of what an exponent is. And a logarithm gives us some sort of number that acts as a base. Not the chemistry base, but as a starting point, if you will. Now in the case of this, the base should be pretty obvious. It's just 10. My base is 10. So what that means is I can use this concept of 10 and moving my decimal point over to the right or the left to make very big numbers manageable and very small numbers manageable. So let's say that I have 1,000 and I want the log of 1,000, the log. So basically what I'm asking is what times itself, and we're using the base of 10 now, so what times, how many tens how many times does 10 have to be, how many exponents of 10 would it take to give me 1,000? Well, what's 10 times 10? That's 100, and then what's 100 times 10? That's 1,000. So the log, so 10 times 10 times 10 equals 1,000, right? So I could say that the log, if I'm using 10 as my base, of 1,000 would be 3. And I'm just going to go ahead and prove it to you guys here. I hope you guys can all see. I've got my little handy dandy little calculator here, and what I'm going to do is I'm going to type in 1,000, and I'm not sure if that's going to focus on there real well. I would just urge you guys to do that with your own calculator at home. And then I'm going to hit log here, and this automatically is set at base 10. Boom, it gives me a 3. So what a log of 3 means is that 10 times 10 times 10 is 1,000, that's 3. Likewise, I could take, let's say, 10,000. 10,000. And I go ahead and I type in 10,000, and then I hit log, that's 4. 10 times 10 times 10 times 10. So you can see what I'm doing is I'm taking these large numbers and I'm making them more manageable via a logarithm, via the agency of a logarithm. Now, if I can do this with very large numbers, can I not do this with very small numbers? And this is hopefully where some of this intuition about the pH scale will come to fruit, or will begin to start to grow a little bit. So what I'm going to do is I'm going to start, and I'm going to say that 1 mole per liter. So I'm going to start here at 1 mole per liter. And I'm going to say that's going to be kind of my starting point. 1 mole per liter. And what I would ask is if it's 1, right? So let's say this is 1, because remember, acid is measured in molar concentration, in moles per liter. So 1 mole per liter. Well, if I hit 1, what's the log of 1? Well, the log of 1 is actually 0. And if you don't believe me, just type in 1 in your calculator, hit log, and it'll come up 0. So 10 to the 0, right? No power. 10 to the no power is going to give me my 1. Okay. So that 0, because that's my exponent there. That 0 is the log. Now let's say that I make that 1 smaller. I make it 10 times smaller to 0.1. So then what I can do is I can go, okay, 0.1, hit the log button, I'll hit the log button on my calculator, and that should give me what? Well, that should give me a -1. Because remember, I'm starting out here at 1, right? If I go up to 100, my log would be +1, right? 10 times 10 is 100. However, because I'm getting smaller, it's not going to be +1, it's going to be -1. And there's my -1. So now let's say that I make it even weaker, and I go to 0.01 moles. 0.01, and I hit the log. That's -2. 0.001, -3, -4, -5, -6, and so on and so forth. So hopefully we're starting to see a pattern when we use a logarithm. When I turn this into a log, I start at 1, and that's just 0, and that's really concentrated. That's a lot of acid. But when I dilute that acid down 10 times, it becomes -1. Dilute it down another 10 times, and -2, 3, 4, 5, 6, and so on and so forth. Okay, hopefully there's some intuition there, and I think in the next video, this should become very clear how this actually turns into the pH scale we all know and love. Okay guys, take care.